protons, neutrons, and electrons. Okay, so the first part is to calculate, being able to calculate the number of protons, neutrons, and electrons. Okay, and so you choose element from the bag or just choose a random element from the periodic table. And actually, I'm going to take a step back. I want you to practice doing it on this practice sheet right here. Okay, so that is chemistry background practice. So we're going to go there. So this document here. Okay, so it says choose two elements with an atomic number of 9 or more and use the periodic table to identify the name, symbol, atomic number, and atomic weight. Okay, so we started off with helium. The number above is called the atomic number, and the number below is the atomic weight or mass number or atomic mass. So if we were going to do this here with helium, the name would be, helium. The symbol is HE, capitalization counts. Atomic number would be the number on top, that number up here, and that is 2. And then the atomic mass is 4.03. And I would take this and I would draw it here. So I could take this and I could just draw it here. Okay, I'm going to undo that just because I think that kind of scooched things up. All right, so now let's choose a different element. Let's choose a different element. Let's use nitrogen. So we're going to start with nitrogen. And if we look here on nitrogen is the number up top is 7, and then the number down below is 14.007. And the symbol is N. So I'm going to go back. I'm going to write that the name is nitrogen. Nitrogen is really important for making proteins, and it's important for our bodies and DNA. The symbol was capital N. The atomic number was 7. Let's just check. Yep, 7. And then the mass number, or the atomic mass, was 14.007. Okay, so let's remember that the atomic number, that number above, this element symbol, is the number of protons in an element. Okay, and the atomic mass is the number of protons plus the number of neutrons, and it's located on the bottom. And we usually round it to the nearest whole number. So the mass number, or atomic mass, would be here would be 14. Here would be 4.03. If we went to a different element, like boron, it would be 10.8. Well, that would round up to 11. Oxygen would be 15.99. That would round up to 16. Okay? So how do we do this? So now what we do is use your periodic table to identify the number of protons, neutrons, and electrons for each element. Okay, so let's do it again for nitrogen. So the name, scooch. The name here would be nitrogen. Nitrogen. The number of protons. Well, the number of protons, remember, is an atomic number, and the atomic number is the number above the element. So when I look at the periodic table, the number above is this number 7. So let's go ahead and type in 7. So that'll be 7 protons. Remember that the number of protons is equal to the number of electrons, unless it's an ion. So we have 7 protons. That means we have 7 electrons. Okay, so now what do we have to do is we have to calculate the number of neutrons. So we take the mass number. Number of neutrons is the atomic mass, rounded to the nearest whole number, minus the atomic number. So the mass number for nitrogen is 14, because I rounded it. 4.007 rounds closest to 14. And then I subtract the top number, or the atomic number, or the number of protons here, minus 7. So let's do that. So it'd be 14 minus 7. 14 minus 7 equals 7. So it has 7 neutrons. All right, that was good. Let's choose another element here just to get the hang of it. One more. Let's do sodium. Sodium has an atomic number of 11. So you can look here, sodium right here, Na. So I'm going to go to the periodic table, scooch over. And all this is on your periodic table, which should be on page 25, the atomic number, atomic mass. So sodium. So I look here at sodium, it has an atomic number of 11 and 22.990. So let me fill that in. So we have the name, which is sodium. Okay. And then the number of protons, well, that's equal to the atomic number. Atomic number is, again, I'm checking here, nothing to remember, it's just right here, 11. 11. So if it has 11 protons, that means it has 11 electrons. So I'm going to write 11. And the number of neutrons, well, that's the atomic mass rounded to the nearest whole number minus the atomic number. Well, the atomic mass here is 22.990 minus 11, the top number, atomic number. So that would be, showing my calculations, 22.99. That rounded to the nearest whole number would be 23. Actually, I'm going to try to strike through so you guys can see. Oh, that's fine. I'll just do it like this. 23 minus 11. So 23 minus 11, 3 minus 1 is 2, and 2 minus 1. So that would be 12. So there are 12 neutrons. So I would put 12. Okay, so that is cool because you can calculate the number of neutrons. If you want to stay around, we'll do one more example. So let's do, my first name is Kristen, so let's do potassium. So we're going to do potassium, and potassium is with a K. So it's right here, number 19, and it has the atomic number of 19. So let's go here. Let's do potassium. Potassium. Number of protons is 19 because the atomic number is 19. And if it has 19 protons, that means it has 19 electrons in the electron cloud. And the number of neutrons, again, is the atomic mass rounded to the nearest whole number minus the atomic number. So atomic mass is 39.098. So right here, 39. That's something I have to show my calculations. Bring this up to give myself more space. 39 minus 0.098 minus how many protons would be? So I'm going to round that to the nearest whole number, so that is closer to 39 than 40 minus 19 atomic number, which would give me 20. So it has 20 neutrons. Okay. So that's how you calculate the number of neutrons. You use